Okay, guys, now let's take a look at part 3 of our lesson on factoring quadratics by GCF and grouping. This time, we're going to take a look at quadratic trinomials, and we're going to factor by grouping again, but this time our a value is not going to be 1. But the process is exactly the same. So let's take a look at what the factors of quadratic trinomials look like when a is not 1. So you can see that in the other examples, both binomials were x. This time, we're going to have a coefficient other than just both being 1. So we're going to multiply again, 2x times x, that's 2x squared, plus 6x, and now distribute the negative 1. And again, we have 4 terms before we combine. And we can see our a is not 1. So again, we're going to be factoring quadratic trinomials that look like this, and we're going to make our way back to the top, splitting the middle term and then grouping. So we get 6x squared minus 15x plus 2x minus 10. Combine our middle terms. And again, our a value is not 1. We'll be moving from 3 terms to 4 terms to 2 factors. And we'll do our last one here. So this gives us 6x squared minus 2x plus 9x minus 3. We have our 4 terms. We're going to combine the 2 linear terms, the middle terms. And we have our quadratic trinomial. Okay, so same deal. We're going to see if there's a GCF. There is not. We can see that our a value is not 1. So again, when we use our big X graphic organizer, the top value is the product of a times c. It is not just our c value. So 2 times 3 is 6, and our b value is 5. So we have only 2 choices here. We're going to split this middle, so we have 2x squared. Bring down our plus 3. We're going to split 5x, and the combination that we're going to have to use is going to be, we can see that 2 plus 3 does give us the 5. So we're going to break 5x into 2x plus 3x, or you could have said 3x plus 2x. In the end, it will not matter. We're going to group the first 2 and the second 2 terms to make 2 binomials. We're going to factor out the GCF, so we're going to factor out 2x. This leaves us with x plus 1. We have plus as our operator. Our GCF in this binomial is 3, and we are left with x plus 1. Again, we are on the right track. Put your 2 GCFs as 1 binomial factor, and then the shared factor is our second factor for this quadratic trinomial. Okay. Remember to pause the video at any point you need if I'm going too fast, or if you want to try to do it before we show the steps. There is no GCF. Our a is 3, our b is negative 7, and c is negative 6. For our graphic organizer, the top value is the product of a and c, and our bottom number is the coefficient of our linear term, the one we are trying to split. So let's go ahead and bring down our quadratic term and our constant. We need to decide what 2 terms that give us negative 7x will we use. Well, that depends on the factors of 18. And again, we're going to be using some negatives and positives because we have a negative product and a negative sum. So the 2 numbers, one's going to need to be negative and one needs to be positive to give you a negative product. We have 2 and 9, and we have a pair of 3 and 6. So which of these would give us a 7? 2, and 9. So I'm just going to put the 2 and the 9. Now we need to decide which one needs to be negative. Well, our 7, we have a negative 7, so the 9 needs to be negative. And so 2 times negative 9 is negative 18, and the sum of these two numbers gives us negative 7. So we're going to have plus 2x minus 9x, and you can see that still gives me back this middle value. We're going to group the first two terms and the last two. Don't let this operator get lost. The GCF in the first one is just x. 3x plus 2 minus 3. So our GCF is a negative 3. Negative 9x divided by negative 3 is positive 3x. Negative 6 divided by negative 3 is positive 2. Check, check. Take your GCFs. This is one binomial factor, and then the shared one is our second, or vice versa. These can be written in the opposite order. It will still multiply out to give us back our original quadratic trinomial. Okay, again, we need to ask, is there a GCF? And these are all even numbers, so I know that there is a GCF, and it's going to be 2. 4 can't divide into 10, so 2 is the GCF. And this leaves me with 2x squared minus 5x minus 12. Now, let's identify our A, that's 2. B is negative 5 now, and C is negative 12. So we're going to split this middle term. And it is A times C on the top, that's negative 24, and negative 5 is our bottom number. So we have 1 times 24, 2 times 12, 3 times 8, 4 times 6. So what combination could give us a negative 5? It looks like it's going to be the 3 and the 8. This is a negative 5 sum, so 8 needs to be the negative. So split negative 5x into positive 3x minus 8x. Now we are going to group our first two terms and our second two terms. Bring down the GCF. Factor out the GCF in this binomial. It's going to be x. That leaves me with 2x plus 3 minus 4. So that is going to be negative 4 is our GCF. So negative 8x divided by negative 4x is 2x. Negative 12 divided by negative 4 is positive 3. Check, check. Bring down your GCF. We're going to have x minus 4 is one binomial factor. And then 2x plus 3 is our second binomial factor. But this quadratic trinomial has 3 factors. Factors are things that are multiplied. 2x minus 4 and 2x plus 3. Okay, let's try one more. Again, let's ask, is there a GCF? Yes, each of these have a factor of 3. So we're going to factor out 3. We're left with 3x squared minus 7x plus 4. Our new A value is 3. Our B value is now negative 7. And 4 is the C value. We are trying to come up and decide how to split this middle term, so we will have 4 terms. So A times C goes on top, 12, and negative 7 goes on the bottom. We have 1 times 12, 2 times 6, and 3 times 4. Now, you don't have to write these out, especially after using them a good while, but just to show where these numbers come from. I'm just writing them out. We know that 3 and 4 can add up to 7, but we need it to be a negative 7, and that does give us a positive product. So negative 7x is going to be broken down into negative 3x and negative 4x. Now let's group the first two terms, the second two terms, bring down our GCF, factor the GCF from these two terms. That's going to be 3x. So x minus 1 minus, we're going to factor out a minus 4. Negative 4x divided by negative 4 is positive 1x. 4 divided by negative 4 is negative 1. Bring down the GCF of 3 times 3x minus 4 times x minus 1. And why don't we try one more? And again, if you want to pause and try this before we go through the steps. The first thing we will ask, is there a GCF? We can see these are even numbers, so we're going to factor out the GCF of 2. And we are left with 3x squared plus 5x minus 2. Our new A is 3, our new B is 5, and our new C is negative 2. We are going to split 5x into 2 terms to give us the 4 terms we need to group. In our graphic organizer, 3 times negative 2, and then our linear coefficient. We have 1 times 6 and 2 times 3. We need to get a positive 5, but a negative 6. So if we use 2 and 3, 1 would have to be negative. That could not give us a 5. So it's the 1 and the 6, and the 1 needs to be negative. And because negative 1 plus 6 gives us positive 5. So we're going to break down 5x and split it into negative 1x plus 5x. We're going to group, and group. Bring down the GCF of 2. Factor out the GCF here, which is x, leaving us with 3x minus 1. We have a plus. And I'm glad we did this example because we've not done this yet. But when it seems that there is no GCF, there really is, but it looks like we've done something wrong. Let's go back and look at this. Negative 1 times 6 gives me that. Negative 1 plus 6 gives me positive 5. We broke this. Oh, guys, look right here. So glad I caught this. I was like, this is not adding up because I was looking ahead and it wasn't going to give me that. So there should be 6x. So we still had the right numbers. I just wrote the wrong thing here. Okay, but nonetheless, now we're going to factor out looks like what, a 2. And then 6x divided by 2 is 3x. And negative 2 divided by positive 2 is negative 1. So you see how I caught that. I could see ahead that this was not going to give me the 3x minus 1 when I had the 5 here. So again, I just messed up, but we fixed it. Okay, moving right along, bring down our GCF of 2. Create this binomial factor, x plus 2. And then our shared binomial